ladies and gentlemen.
Before we talked about right triangles, now we're going to start to talk about some special right triangles where the sides have a really, really nice ratio between them. So the first triangle we're going to look at is a 30, 60, 90 triangle. So I want you to imagine we have a lovely equilateral triangle. All of the angles are 60 degrees, all of the sides are the same length. For our intents and purposes, let's call that length 2. So all of these lengths are 2 long. Now I want to draw the height of the triangle. I want to take the vertex at the top and drop a line perpendicular to the base at the bottom, and I get 2 right triangles in that process. So let's take a look at one of those triangles. Because I split the top angle in half, it goes from 60 to 30 degrees. That gives me a 60-degree angle here, 30-degree angle there. 60 plus 30 is 90, which gives me 90 left to work with, making this a lovely right triangle. And because of how I split it, I know that the bottom side is 1 and the hypotenuse is 2. We can figure out what the third side would be with Pythagorean theorem. So we can do 1 squared plus question mark squared is equal to 2 squared. Well, 1 squared is 1, question mark squared, we're just going to leave that as is. 2 squared is 4, meaning that the question mark squared is equal to 3. Well, to undo a square, we square root. So the question mark is equal to the square root of 3. That's a little bit weird. But it works, actually, all the time. Anytime that we have a 30-degree angle, a 60-degree angle, a 90-degree angle, the side across from 60 is always going to be the square root of 3 times larger than the shortest side. In fact, these ratios always work, so you may see them with an x next to them. So we might see like 1x, square root of 3x, and then 2x as the ratio. Or you might see like 1, square root of 3, 2. I like to remember it as 1, 2, square root of 3. It's going up in number, 1 and then 2 and then 3, but the 3, being the largest number in the set, gets the square root, which makes it about 1.7 something. So that's how it still works with it not being the longest side, because 1.7 is less than 2. So how does this help us? Well, in pre-calculus and calculus, we'll talk about the unit circle. It's lovely, it's beautiful, it's wonderful. But for our intents and purposes right now, it's going to help us cheat to solve some questions a little bit nicer than having to do Pythagorean theorem every single time. So let's dive in. So this first question here, the hypotenuse of a 30, 60, 90 triangle is 12. What are the values of its legs? So here I can't even use Pythagorean theorem because I only have one side and not 2. So we have to use what we know about this. Well, the 12 is with the hypotenuse, meaning that the 12 is the 2x side. It's the 2 side. The side across from the 30 is the smallest side, which is half of the largest side. So if the largest side is 12, then this is equal to 6. Y is root 3 times larger than the shortest side. So if the shortest side is 6, then y is going to be 6 times the square root of 3, or just 6 square root of 3. And that's it. There's no more to this. There's no trick here. It's just using that ratio in real time. Let's try another one. So the perimeter of an equilateral triangle is 24. What is the height of the triangle? Well, an equilateral triangle, I'll do my best to draw one here. That's not quite good. Let's try one more time. That's better. So we know the perimeter is 24. Well, equilateral triangles, all the sides are the same length, so 24 cut by 3 would be 8. Each side is 8. If I want the height of the triangle, the altitude of it, I'm going to draw a straight line down from one of the vertices, makes a right angle. Well, that makes a 60 and a 30-degree angle, so we have a 30, 60, 90 triangle. The longest side is 8, so what this did is it cut this into a 4 and a 4, which means that the side across from 60 is root 3 times larger than the side across from 30, which means that the height is equal to 4 square root of 3. And that is it. So let me know if you have any questions. Otherwise, I look forward to seeing you in the next video.